Today, we're going to learn about exponents. And I'll just tell you right now, there's a lot of rules, but hopefully if you follow the patterns, everything should work out nicely. Let's go. Let's start off with something that should be relatively easy. Base exponent power. Now, the only thing I want to show is that the 3 is the base and the 4 is the exponent. So many people think 4 is a power. No, 4 is the exponent. Together, these base and exponent form a power. So this is 3 to the exponent 4, which definition means you're going to multiply 3 4 times itself 4 times. Gives you 81 if you wanted to work it out. Let's make a quick note here. 3 times 4 is not the same. This is a product, not a power. And so usual rules of times tables would take effect. Okay, so where does this come a little bit complicated? Well, we can have different types of exponents. So as we just worked out, 3 to the 4 is the 3 multiplied 4 times. If I gave you an extra little number in front, a multiplier of 1, I'm going to use this to show you how this rule can apply to different kinds of exponents. So let's take a look at 3 to the 3. We're going to put that 1 in front, okay? Doesn't change any values, and it's basically multiplying by 3 times. So 1, 2, 3. Smaller number, it's going to be 27. Moving along, let's say, what about 3 to the 2, or 3 to the 1, or 3 to the 0, right? And this is where that little 1 multiplier in front is going to be helpful. When we're doing 3 to the 2, it's 1 times 3 times 3, right? We're multiplying 2 3s, we get 9. When we have 3 to the 1, people say, well, you're just multiplying 3 once, right? Well, yeah, but you're multiplying it by a 1, and that's what gets us that 3. So what does 3 to the 0 mean? It means we're going to take that 1, and we're not going to multiply it by anything. 0 3s are going to be multiplied. So our answer is just 1. Now, if you notice the pattern here, look at the 81. If you divide this 81 by 3, you get 27. You divide by 3, you get 9. You divide by 3, you get 3. And just by pattern, you divide by 3, you're going to get 1. All right, so it's all about the patterns. But let's throw something at you as we do in math. What if, okay, oh yeah, just that reminder that anything to the 0 is equal to 1. But what if I put the next exponent down? We have our countdown, 4, 3, 2, 1, 0. What would come next? Negative 1. And what would that mean? Well, it's going to mean you still have that 1 in front, but instead of doing multiplication by 3, you're going to divide by 3. And that would give us 1 divided by 3, or 1/3 fraction. And so to remember that a negative exponent is going to mean division. So we know what 3 to the 4 means. We know what the base and the power, the exponent are. We know that anything to the 0 is going to equal 1. And negative exponent is going to mean to divide. Hopefully things are looking okay so far. You're going to stare at this for a while, but it's all about patterns. Okay, moving on. We now want to look at a couple of the rules. What happens when we multiply 2 powers together? And let's just remember here, the 3 is the base, and in the first one, the 4 is the exponent, and the 2 is the exponent in the second one. We're multiplying these two things. That's what product means. The bases match. That's important. So breaking this down, 3 to the 4 would be 3 multiplied 4 times. 3 to the 2 would be 3 multiplied twice. And then we can just sort of say, well, what's this all going to equal? We really don't care about the number right now. Yeah, it's equal to 729. But what we care about is, can we put this together using a rule? So we're allowed to get rid of those brackets because this is all multiplication, right? And we can mix around multiplications. And so now we just have a list of 6 3s multiplied. So that's going to be 3 to the exponent 6. Notice I didn't say 3 to the power of 6. It's 3 to the exponent 6, or 3 to the 6. Now there's a shortcut rule that you got to learn, and that basically is saying that when you're multiplying 2 powers with the same base, we could just add the exponents. And so 3 is going to be 3 to the 6. You add those 4 plus 2. Add the exponents, and you keep that same base. The bases have to match. That is the product of two powers. We're multiplying two powers together. Now, my next example is talking about the power of a power. So what happens if I've got 3 to the 4, and this time I'm not multiplying it by another power, I'm just squaring it. I'm putting an exponent on the actual power. Well, definition-wise, that means I've got 3 to the 4 times 3 to the 4, right? You multiply it by itself. Well, just like I did before, I can remove the brackets. How many 3's do I have in all? 8 of them. So it's going to be 3 to the 8. So that means this is going to equal 3 to the 4 times 2. In the previous question, we ended up adding the exponents. In this one, we multiply the exponents together. And one way of kind of looking at that is to see that this bracket here, there's like between the 4 and the 2, it's like a multiplication, all right? That times 4 bracket 2. Anyways, long story short, you multiply the exponents with a couple of reminders, okay? The base stays the same, and so you don't square the 3. And it has to have only one base. Now, there are a couple of other rules. We're going to get to those as we move ahead. I will have to make another video for that in the future. So that's it for now. Thanks and have a good day.